Laboratory apparatus used for measuring volume. The first category of apparatus are used to measure volume. These apparatus include the following. The first one is known as a beaker. Here we have a nice diagram of a beaker, and on the left hand side we have a very nice picture of a beaker. The picture of a beaker shows a 250 milliliter beaker, and you can see that it has got markings which we usually call graduations, or sometimes you can call them calibrations. The use of a beaker is for measuring approximate volume. However, we have other uses that a beaker can perform, such as holding liquids or solutions. They are used when stirring, mixing, and heating liquids or solutions in the laboratory. The next apparatus used for measuring volume is known as the conical flask. Observe, this is a diagram of a conical flask, and again the picture of a conical flask. Again, you can observe the graduations. That means that a conical flask can be used to measure volume. Other uses of a conical flask include holding liquids. They're used during titrations and other general experiments, as well as I have already said, measuring approximate volume. Now, the term titration is a special new term, very nice word you need to learn. It means a type of reactions that involve acids and bases. However, this is just a very simple way of describing titration. When we get advanced, we will learn a lot about titrations, a very interesting thing in chemistry. The next apparatus is known as a measuring cylinder. Here we have a nice diagram and a picture. A measuring cylinder is used to measure approximate volume of liquid or solutions. We have different sizes of a measuring cylinder. For instance, we have the 10 milliliter measuring cylinder. You also have a 20 milliliter measuring cylinder, 50 milliliter measuring cylinder, 100 milliliter measuring cylinder, and so on. It all depends with the amount of volume you need to measure. After that, we have a syringe. A syringe is like the one you have already met when you're in hospital and you're sick and the doctor decides to give you an injection. However, here's a nice diagram just to remind you how it looks like. And another picture of the same. A syringe, take note, is used for measuring accurate volume of liquids or solutions, usually in small quantities, but not all the time, because we have syringes that are big that can measure up to even 100 milliliters. And therefore, for instance, this picture of a syringe here can measure accurately between 0 and 10 milliliters. The same applies to the diagram. The diagram represents a syringe that can measure up to 10 milliliters. I'm sure you know it's very easy how to read a syringe. For instance, in this diagram, you can see that the mark, the piston of the syringe shows that the volume in this syringe is 5 milliliters, slightly over 5. Anyway, you're going to meet these apparatus and interact with them. It's going to be very easy and a lot of fun. The next apparatus is the burette. Here is a nice picture. As you can see, it has a long tube, and this one here is known as the tap of the burette. You can never have a burette without the tap. You will soon know why. Then a nice diagram represents a burette now in upright position. A burette is used for measuring or delivering accurate variable volume of liquids or solutions accurately. When you look at this diagram here, I want you to focus on the levels. At the top we have 0, meaning when this burette is filled with a liquid or solution to this level, we can read the volume as 0 milliliters or 0 centimeters cubed. However, when this tap is opened, the liquid flows out of the burette into another container up to a level that is somewhere here. For instance, when the tap is closed, you read how much volume of liquid has been delivered into the other container. In this case, it would be 20 cubic centimeters if the level has dropped to this level. Fine, let us have another picture to show us how this happens exactly. Look at the left hand side of your screen and you see a burette in use. As you can see, the level of liquid here, and the tap is open and the liquid is delivered into this conical flask. However, when you get to the lab, you're going to use it practically and it's going to be very easy to understand, but I hope that one would suffice. Next, we have what we call a pipette. Here is a picture, a diagram, and here we have a picture. Notice there is a certain line right here which we call the mark on the diagram and on the picture, as you can see me highlighting. This mark indicates the level of liquid or solution that should be filled in the burette. Now let us see what it is used for. A burette is used for delivering fixed volume of liquids or solutions accurately. For example, this pipette here is used for delivering 10 milliliters of liquid or solutions accurately. We also have different sizes of pipettes, like the ones you see in this picture. This one here indicates a zoomed out picture of the bulb, this part here, which we call the bulb. It is where the details are indicated. For instance, in this one here, it measures exactly 25 cubic centimeters. Again, the next one shows a pipette that measures exactly 50 cubic centimeters. And finally, we have this one here that shows a pipette that measures exactly 100 milliliters. These apparatus that measure accurate volume usually do so at a certain temperature. I hope you can see, but if you zoom in to this part, you'll find that we have a temperature of 20 degrees Celsius indicated. That means these pipettes measure accurately at 20 degrees Celsius, usually about the room temperature. Next we have volumetric flask. Here is a nice picture of a volumetric flask in the diagram. A volumetric flask is used to measure fixed volume of liquids accurately. However, as opposed to the pipette, you see the difference is obvious. The volumetric flask can measure a large amount of volume, and also they're just used for measuring and storing the solutions, but a pipette is used for delivering the solutions. Now it also has a mark that you can see me highlight on the picture and diagram. For example, in this picture, when you fill up liquid or solution up to this mark, you would have measured exactly 500 cubic centimeters or 500 milliliters. This picture represents a volumetric flask that measures accurately 100 milliliters at 27 degrees Celsius.